Mechanism we have already studied that for a beam, if it is deflected, the curve will be linear and it won't regain to that original position, so that is unstable. Next, what we can study is about certain cases we can study. First is, this is case 1. So in this case 1, what is happening is we can see about a beam which is having this, that is statically determined, we can see. So first is, this is cantilever that I have already mentioned, that is it is statically indeterminate. Let's check how it is statically determined. So here S equal to 2 and R equal to 2, because summation of this B equal to 0, summation of this M equal to 0. So this is external indeterminacy is what? External indeterminacy means R minus S, that is external indeterminacy. We can write here external indeterminacy means what? R minus S. Through this we are going to find, so R minus X it's what? 0. So it's statically determined structure. For this fixed beam like this, here 3 and here 3, there is 3 reaction, there is no external load acting, so here we will be considering this horizontal, as we are considering it as general beam. Here the DSE equal to, that is external indeterminacy, equal to R minus X. So what is this R reaction? So first, before getting into that, summation of this H equal to 0, summation of this B equal to 0, summation of this M equal to 0. So next in that we can see summation of H equal to 0. So there is 3 equilibrium equations and reaction is what? 3 plus 3 6. So here we'll be getting 6 minus 3 is what? 3. It is externally indeterminate structure. So this is indeterminate structures, this fixed beam. Next is about the fixed beam which is having this supports. Here we can see, here there is 3 reactions, here there is 3 reactions, here 2 reactions, here 1 reaction. So number of reactions will be what? 3 plus 3 6, 6 plus 2 8 plus 1 it will be. Okay, so here okay, so can I make a change, because we have already seen this fixed. So here it is vertically loaded. I'm just gonna see about this vertically loaded. So there will be one moment and one vertical. So suppose, so there will be 2. So here what it will be is, number of reaction is 4 plus 3 7 plus 1, it is 8. And we can say summation of H equal to 0, summation of this V equal to 0, summation of this M equal to 0. Here this we will considering external indeterminacy, R minus S. So R is 8 and S is what? 1 2 3. So 8 minus 3 is nothing but this 5. So it is externally indeterminate structures. So this is externally indeterminate structures. Next we can see another example. So here we can see, okay, we have already find this fixed. Next example is the same example I have mentioned. The same example, for the same example I have already mentioned. If there is a external load happening like this, then there won't be any horizontal reaction. So this we can cut down, and here instead of 2, it will be what? Okay, there will be, okay, we can calculate this reactions. Here it won't be, so here it will be 2. So 2 plus 2. So the reactions will be here, this one, and there won't be any horizontal reaction. So here, okay, so 1 2 3 4 5. So what is happening? So reaction equal to 5, and S equal to summation of this V equal to 0 and summation of M equal to 2. So this is what? Statically external indeterminacy is what? R minus S. So 5 minus 2 equal to 3. Next we can see about this rigid joint frame. So rigid joint frames, here you can see that support, you want to see that support, and what? It is must, because support, we're looking at the support is must. Okay, so okay, fixed, and here it is being joined. Here what is happening, this is this reaction. So number of reactions what? So here 3 2, because I'm considering it is hinge. Okay, so hinge and fix it. So here it is 2. So number of reaction is 5, and number of equilibrium equation already we know, and while calculating DSA it's 2. So the same, okay, so we can calculate for this. Okay, here the reaction is what? Here 2, 2, here it is 3, here 2, 1. So total number of reaction is 5 plus 5, it's 10 what? It's 10. So number of equilibrium equations 3. So DSE equal to what? 7. So it is also externally indeterminate structure. Next we can say, here we can see this, we have just find this rigid joint frames. Next is about this pin joint plane frame. So pin jointed plane frames. Okay, so this is here we can see that reaction is what here, as it is pin joint. Here the reactions is what? 2, and here also I am just giving this, so to a 1 1. So the reaction is 2 plus 3 plus 1, it is 4, and number of this equation it will be what? It will be 3. So ds equal to 1. So it is also externally indeterminate. And if we have the beam which is like upward also, it will be the same. And if there is external load acting, so there will be deflection like this. Okay, so if I'm giving this load, so there will be deflection, and each joint, so each joint is pin joint, so load is acting on that pin joint. So if the load is acted, it's not called stress. If the load acts on the member, it bends. And if this member got curved like this, it's also not called a stressed. If it's bent like this, it's not a stress. And if some load is acted, it's not a stress. And if it have that curved structure, it's also not stress. Next we can find this, internal indeterminacy, that is DSI. So for this DSI, it should be 0, DSI greater than 0, DSI less than 0. So it is statically determined, statically indeterminate, so it is unstable. So for that DSC, that is for that external indeterminacy, what we have learned, for that external indeterminacy, so ds equal to 0, it is externally determined, and ds greater than 0, it is externally indeterminate, and dsi less than 0. So same as that dsa, that is external indeterminate. Here for the beams, I'll be showing for the beams. Okay. Okay, here what is happening is this, is there any internal indeterminacy happening? So here also dsi equal to 0, here also dsi equal to 0.